Evaluate arc cosecant radical 2. Class, what's another way of writing arc cosecant? Try that again. Class, what's another way of writing arc cosecant? Inverse of cosecant. Okay, we've done sine, cosine, tangents. We didn't really do cotangents yesterday. Okay, what's our first step? Make it into an equation. What's your favorite Greek letter? Theta, someone said. Okay, now what do? We switch them. What do I have now? Cosecant of theta equals what? What was my hints? What were my hints? What's the letters for cosecant? X, Y, and R. Okay, this is a hint. So essentially I'm looking for what? What's the reciprocal identity of cosecant? Some of you guys struggled that on your last quiz. It is sine. So y over r, right? We're going to look at sine. Here's my second hint. How do you make this a fraction? Put it over 1. Okay, what does this mean? If I have y over r, which is essentially 1 over radical 2. So you see r over y or radical 2 over 1. Now, think about that. Radical 2 is not on your unit circle, is it? What would happen if I flipped it? If I flipped it, I would get y over r, or 1 over radical 2. Now, does this look funny to you? What would you do? You would rationalize it. So essentially what I'm looking for is, because we flipped this, you can't just flip anything because you want to. Right? You can't just decide to do that. Essentially what you were finding is we found sine of theta. Does that make sense? Because cosecant is, again, r over y, but this doesn't make sense to us. You could find sine of 1 over radical 2. We normally can't find that, but this is now at least something we can find. Okay. Put your finger at where sine is positive. Out. Where is sine positive? Quadrants 1 and 2. Remember, sine is a second order pair, so 1 pi over 4 and 3 pi over 4. Okay. Pay attention now. So let's review what we've done so far. We made an equation. I switched it. I kind of changed it to make it more digestible, something that you know. Cosecant is not easily found on your unit circle, but sine is. So cosecant is r over y. Make this a fraction, flip it. Basically, I have sine of theta equals radical 2 over 2. And then where is sine positive? These are the two locations. Okay, now pay attention. What did we take the inverse of? Sine or cosecant? We took the inverse of cosecant. So when you're looking at your the domain, as I described it to another student, Mr. Ng, does that mean you're looking at the range on this chart? That is correct, because you're taking the restricted domain of the inverse of sine. You can call this the new range. So new range or restricted domain, you're looking at cosecant. I'm going to write it down. This one tells me negative pi over 2. to 0. Basically, that means you can't include 0. That's all it basically means. We've been working on common denominators. So I have a 4 here, so the common denominator is, lowest common denominator is 4, so I'm going to multiply this one by 2 over 2. It gives me equivalent fractions, and I can compare them. So essentially this is negative 2 pi over 4 and 2 pi over 4. Class, yes or no, does this fit within our restricted domain? Yeah, this is like 1 pi over 4 would be like right here. So it's like 1 pi over 4, acceptable. Okay, 3 pi over 4. That'd be somewhere over here on the number line, right? Now, if I do what happens if I did a coterminal angle? 8 plus 3 is 11. What happens if I did 3 minus 8? Negative 5 would be too much. Okay, so our only answer for this problem is theta equals pi over 4. A lot of students are asking, why are you subtracting or adding by 8? Remember, a full rotation is 360 degrees, or 2 pi. 2 pi is equivalent to 8 pi over 4. And this is how we took the inverse of cosecant.